Good morning, students. Today again we are going to start with the chapter metals and non-metals. And as we were doing the properties of chemical properties of metals, continuing with that topic. Now, the next topic is the reaction of metals with metal salt solutions. So in these reaction, basically the displacement reaction take place. So on the basis of reaction of metals with oxygen, water, acid, it is found that some metals are highly reactive, some are less reactive, while some other are least reactive or almost unreactive. Thus metals can be arranged on the basis of their relative reactivity. The arrangement of metal in vertical column in order of their decreasing reactivity towards downwards is called activity series or reactivity series of the metals. So we'll continue with this topic. Now, a more reactive metal displaces a less reactive metal from its salt solution, and this is the displacement reaction. So the relative reactivity of metal is found on the basis of displacement reaction. The basic principle of these reaction is that more reactive metal can displace a less reactive metal from the solution of its salt. Thus, if metal A, like here is magnesium is metal A, plus it reacts with the salt solution of metal B, that is copper sulfate, then metal A can displace metal B from its salt solution. Okay, like in this. So there is salt solution of metal A plus metal B. Okay. So this is a reaction when magnesium displaces copper from copper sulfate solution. So magnesium, as it is more reactive than copper, so it displaces copper from its copper sulfate solution to form magnesium sulfate plus copper metal. Now if the reaction is opposite, if I take copper here and magnesium sulfate here, then there will be no reaction because copper cannot displace magnesium as it is less reactive than magnesium. So we should see first of all that what kind of reaction is given. Next is zinc displaces copper from copper sulfate solution. You have done this reaction a lot of times. So see, this one is of magnesium powder. We are putting in the blue copper sulfate solution. After reaction, what happened? The colorless magnesium sulfate solution is there in pieces of copper. You can see in the below. That one is the first reaction. Okay. So when zinc reacts with copper sulfate, if he is saying the pieces of zinc are dipped in copper sulfate solution taken in a beaker, the blue color of copper sulfate solution start fading and reddish brown particle of copper are found to settle at the bottom of the beaker like this. That like in the magnesium reaction it took, similar in the copper, zinc with copper. Okay. So this reaction shows that this reaction shows that zinc is more reactive than copper. If copper plate is dipped in zinc sulfate, if we inverse it, here we take copper and here we take zinc sulfate, then there will be no reaction. Why? Because copper is less reactive than zinc. Okay. Now next is reaction of iron with copper sulfate solution. These are the iron nail. We will take one iron nail and we will put it in the blue copper sulfate solution. After 15 to 20 minutes, what we will see, the green iron sulfate solution is formed and copper metal, it has a reddish layer deposit over it. It means iron has displaced copper from copper sulfate solution to form FeSO4, that is iron 2 sulfate, which is green in color, plus copper, which is reddish brown in color. Okay. So again, this shows that iron is more reactive than copper and no reaction take place if copper wire, if instead of iron I take copper here, if I dip copper wire in the iron sulfate, that is a ferrous sulfate solution, then there will be no reaction. Okay. So this shows that iron is more reactive than copper. One more reaction is there if copper plate or wire is dipped in colorless silver nitrate solution. Now the reaction will be Cu plus AgNO3. Silver nitrate formula is AgNO3. That is a colorless solution. Now what will happen, as copper is more reactive than silver, then it will displace copper from silver nitrate solution. So there will be formation of copper nitrate CuNO3 whole twice plus silver. Okay, and copper nitrate has blue color solution. So this shows that again that copper is more reactive than silver. Now, based on above all these reactions, we can conclude that it has been it can be studied between any metal and the solution of salt of other metal to compare their relative reactivity. And the relative reactivity or activity series of metal is obtained, and you can see in the figure, this is a chart or a table shown here, and hydrogen, though not metallic, is included in the series. Why? Because like metals, hydrogen can lose electron to form positive ion. That is why it is being included. So, if we see the reactivity series of metal, the arranging of metal in decreasing order of their reactivity is called reactivity series of the metal. The most reactive metal is potassium is placed at the top of the series, whereas the least reactive metal, that is the gold, is placed in the lowermost position. So gold and silver, as you can see in the reactivity series, so they are placed in the lower column of the table. Okay, hence we can see metal lying above hydrogen, and they are more reactive than hydrogen. Here is hydrogen. All these metals, they are reactive, more reactive than hydrogen, and they can displace hydrogen from its compound like water or acids. On the other hand, metal lying below hydrogen, these one, in the reactivity series are less reactive than hydrogen and cannot displace hydrogen from water or acid. So why we can say why some metals are more reactive while others are less reactive? Because metal are the elements which can lose electron and positive form the positive ions. The more easily a metal can lose electron is more reactive it is. And one more question arises, why some metals are more reactive than hydrogen while others are less reactive? Because metal which can lose electron more easily than hydrogen are more reactive than hydrogen. Hence they can displace hydrogen from the acid. And the metals which can lose electron less readily than hydrogen are less reactive than hydrogen. Hence they cannot displace hydrogen from the acid. Okay, this is how you can remember the reactivity series in the short form. Please send lions, cats, monkeys and zebra into lovely hot country. Signed, Journal Penguin. This is a short form by which you can learn, and the symbols are written here of the elements with the element's name. Now one more short form is there. Please stop calling me a cute zebra. I like her call smart goat. This is also one of the short form to remember this reactivity series. So students, I think you must be clear about the reactivity series, the reaction of metals with oxygen, with water and with acids, and how the metal they displace hydrogen and how they do not cannot displace the hydrogen. So with this reactivity series, we conclude that metals, their reactivity is divided into three types: metal of high reactivity, metals of middle order reactivity, and metals of low reactivity. Okay.